Hello and welcome to Cannon County High School Algebra 2. Today we are going to be looking at graphing the sine and cosine functions. Yesterday we looked at periodic functions, and the days before that we talked all about sine and cosine and how to find their values on the unit circle. Today we're kind of putting all that together and we're going to actually graph what they look like. So Mr. Lyon, as always, I'm going to have you sit over there and let's get started. We are going to graph these very similarly to how you did in Algebra 1 by just making an XY table and plotting some points and seeing what happens. Okay, so I'm going to take out my cheat sheet here that we made the other day of what the sine and cosine of all these special angles are, just to help me out. And let's go from there. Let's see. Graph y equals the sine of x. If we put a 0 in for the sine of x, well, we know that the sine is the y-coordinate, so for 0 degrees, the y-coordinate is 0. So for the sine of x, I know that that's 0, and I can put a dot right there. How about 30 degrees? Well, 30 degrees says it's a half, which is 0.5. So I'm going to graph 30 degrees as 0.5. So let's see, that's about a third of the way between 0 and 90, so 0.5, let's see, that's going to be right about here. And you might be saying, well, why don't we just use the calculator to help us figure these out? Because the calculator has a sine and cosine button. And you're right, so let's start doing that. The reason we haven't done that yet is because it's important that you know how to find the sine and cosine in simplest radical form for a lot of problems. But for graphing them, we're just going to be using decimals, so let's go ahead and use the calculator for that. All right, I've got the Calculate 84 app here on the iPad, and I would suggest using that. If you find the sine button, which is right here, if you take the sine of 30 degrees, we know that it's going to be a half. So let's just make sure that that's right. The sine of 30 degrees. And when I hit enter, it says, well, it doesn't say a half. There's a problem. Obviously, either the calculator messed up or we messed up. Let's go to the mode. Notice on the mode that it has radians and degrees, and notice that radians is right now the one that's highlighted. So my calculator's in radians mode, and I'm doing degrees, so I need to change that. So highlight degrees and hit enter. Okay? Then hit the second button and the quit button to go back to where you were. And let's try that again. The sine of 30 degrees. This time, hopefully, it says the right answer, and it does, 0.5. Okay, so let's keep going. 45 degrees. Well, we know from our reference triangle that that's going to be the square root of 2 divided by 2. What is the square root of 2? What is the square root of 2 divided by 2? Well, according to the calculator, it's 0.707. Is that the same as the sine of 45 degrees? I sure hope so. Otherwise, I've been lying to you the last few days. 0.707. So 0.707 is what we're going to graph on our graph here. So at 45, that's halfway. 0.7 is a little bit higher. Okay, 60 degrees. According to the unit circle, 60 degrees has a sine of the square root of 3 over 2. All right, well, now that we know that the calculator is doing this correctly, let's just do this. What's the sine of 60 degrees? It is 0.866. 0.866. So here we go. 60 degrees is 2/3 of the way. That's a little higher yet. And then finally, we know that for 90 degrees, we know all the way up here, we've got 1 is the sine. So that's going to be 1. So if I graph this, it looks kind of like that. Does that look familiar? Yeah, that's just like the beginning of our Ferris wheel problem yesterday rather. So now you know if you keep going on that unit circle, by the time you get to 180, you're back down here to 0. And when you get to 270, you're down here at -1. And so on and so on. Back up to 360 is at 0. 450, and it looks just like the Ferris wheel problem we did yesterday. It goes back and forth and so on. And this doesn't stop at 540, it keeps on going, and this doesn't stop at 0, it keeps on going, because you could have negative angles, of course, as well. That just means that the angles are going in a clockwise direction. So you can see that the sine graph looks where it starts at 0, and then it goes back and forth like that. Let me ask you this. What is the period of this function? How many degrees does it take for one rotation? Well, it starts at 0, goes up, goes back, 360. The period is 360 degrees. What is, oh, this says period, that shouldn't say period. What is the amplitude? The amplitude is the distance from the midline up to the maximum. So how far is it from there to there? Or from the midline down to the minimum? How far is it from there to there? Well, it's 1. So the graph of y equals the sine of x has a period of 360 and amplitude of 1. It looks like this. And again, it would keep on going forever in each direction. Okay, let's try cosine. Okay, very similar. We're going to use our reference angle or reference card here again. At 0 degrees, well, now it's the x-coordinate. At 0 degrees, the cosine is 1. So I'm going to graph that point. At 30 degrees, the cosine is the square root of 3 over 2. Well, we know from the previous problem that the square root of 3 over 2 is 0.866. So that means 1/3 of the way down. It's coming down here a little bit. 45 degrees has a cosine of the square root of 2 over 2. Well, we know from the previous problem that that's 0.707. So it keeps coming down. At 60 degrees, it's a half, 0.5. So at 60 degrees, we're all the way down here to 0.5. And at 90 degrees, the cosine is 0. So we've gotten all the way down to here. So from here to here, it looks like that. It looks just like the sine graph, except instead of starting at 0, it starts up here at 1. And instead of going up, it goes down. But everything else is pretty much the same. By the time we get to 180, it's going to be down here at -1. By the time we get to 270, it's back up to 0. At 360, back up to 1. 450, back down to 0. 540 at -1, and so on. Again, this keeps on going forever that way. This keeps on going forever that way. Okay? So what's different about the sine and the cosine graph? Well, it looks like they have the same period, right? This has the same period. It goes from 0 to 360 for one revolution. And the amplitude is still going to be 1. It's the same. The only difference is it looks like it's shifted over. Doesn't the cosine graph look just like the sine graph if it were to start at 90 degrees? Look up here at the sine graph. If I were to just start here, it almost looks like it's the same thing, just shifted over 90 degrees. And that's because it is. All right? Now that you know what they look like, all right, now let's take a look at some graphs that we can do quickly and easily on the calculator. We're going to look at graphs that follow this form. Y equals a times the sine of bx, or y equals a times the cosine of bx. Okay? And let's graph a couple of them. And let's use the calculator. Since we have a graphing calculator, let's graph some things on it. Let's graph y equals 3 times the sine of x. So on your graphing calculator, hit the y equals button. We've graphed things on this before. Before you do that, hit the window button, which is right here. And we're going to change the window button to this. Yours probably says something like from -10 to 10 and from -10 to 10. We're going to go from 0 to 540 degrees. We're going to have it put a mark every 90 degrees. Let's put the y minimum at -2 and the y maximum at 2. Okay? And now let's graph y equals, let's start out just with plain old sine of x and see what happens. Sine, and then remember the x button is right here. So y equals the sine of x. What does the graph look like? Well, it looks just like what we did by hand. You can trace on this graph, hit the trace button, and you can move left and right. At least you could. Let me hit that again. Hit the y equals graph. Let's see, trace. Well, it's not liking that right now, but basically you get the idea. We're going up and down. Let's go to y equals, and let's change that. Instead of the sine of x, let's do 3 times the sine of x. Now, what should change? What changes here? Yikes, what just happened? All right, what happened? Well, it looks like we have to zoom out to see what's happening. So I'm going to hit the zoom button, and I'm going to choose zoom out. All right, it's zoomed out, but not quite enough, so I'm going to do that again. Zoom out. All right, what happened? Well, it looks like the period stayed the same. It still is, let's see. I'm not sure why it's not letting me trace, but anyway, what happened to the amplitude? The amplitude, you can see, is now up here at 3. So what happened is this right here, this 3, which in our equation is the A, that controls the amplitude. So the amplitude is the number that's in front of the sine of x, or in front of the cosine of x. Let's take a look at what happens. Let me go back and change this to the sine of x again. Okay, there's plain old sine of x. What happens when you put a negative in front of the sine of x? Remember what happened when we put a negative in front of the x squared on a parabola? What that did is it changed the parabola. Instead of pointing up like this, that changed it so it pointed down like this. So what do you suppose happens to our graph of sine of x if we go back and we put a negative in front of the sine of x? Well, remember, sine of x goes up. Now what happened? Instead of going up, it goes down. So if there happens to be a negative in front on that, that just means your graph has flipped, just like it did with parabolas. Okay? All right, let's try another one. Let's try the sine of 4x. Let's try this one. Notice this time, what's the amplitude going to be? The amplitude should be 1, but what is this 4 going to change? Let's try it. Let's get rid of that. Let's type in the sine of 4x. Okay, well, the amplitude is still 1, but what happened? Well, now the graph kind of squished together. Obviously, the period changed. Instead of taking 360 degrees to get from there to there, I'm going to calculate a value here. I'm going to ask it to figure out what y is equal to when x equals 90. I'm not sure if you can see that or not, but right there it says when x is 90, you can see that y is equal 0. So instead of taking 360 degrees to make one full rotation, you can see it only took 90 degrees. So for this one, the period is equal to 90 degrees. Now you got to put on your thinking cap and say, well, if the period was normally 360 and we got 90 because there was a 4 in front of the x, then obviously what did we do to the 360 to get the 90? Yeah, we divided by 4. 360 divided by 4 is equal to 90. So this number right here controls the period. You take 360 divided by whatever that number is. Okay, so on these equations up here, A equals the amplitude. And if A happens to be negative, the amplitude is still positive. It just means that it goes down instead of up. Or if it's a cosine, it's just flipped. All right, for the period, that means that the period is going to be 360 divided by whatever B is equal to. Okay? So let's try to figure this out. Let's say this was like a test, and I asked you to figure out what is the amplitude and period of this without even using a graphing calculator. You shouldn't need one. The 3 is the number in front of the cosine, so the amplitude is 3. The period is going to be 360 divided by whatever number is in front of x, which in this case is 2/3. So what's 360 divided by 2/3? Well, you can probably figure that one out in your head, but let's do it on the calculator anyway. Let's make sure you can see this. 360 divided by 2/3 is 540. So that means this one would have a period of 540 degrees instead of 360. Okay? If we wanted to check that on here, we could. Let's see here. We're going to go to 3 times the cosine of 2/3 times x. What happens? Well, you can see the period is 3, right? All the way up here at 3. And the amplitude is 3, not the period. And then how far is it from here to here? Well, it looks like that's 400 and that's 600. Let's see if it really is at 540. So I'm going to hit second and calculate a value. And I'm going to choose, what did we just say? 540. If it says that that's equal to 3, then we know we got it right. Yeah, 540 gets us right up to the top. So that's one full rotation. How about this one? What's the amplitude? Is it -6 or is it +6? It's +6 because amplitude is always positive. That just means if we're going to graph this, instead of the sine graph going up at first, it's flipped and it's going to be going down at first. And what is the period? Well, it would be 360 divided by the number in front of x. 360 divided by 2 is 180. So let's try some of these now on the IXL. I'm going to bring the computer over here. Let's go to IXL Z11 and let's just try some of these because I'm going to want you to try some on your own. But the computer does, I think, a pretty good job of showing how to do this. I'm going to zoom in on this just a little bit so you can see it a little better. But it says graph the function f of x equals sine x. And the way it's going to do this is it's going to give us the graph and then it gives us two choices. Do we want to choose this graph or this graph? Well, remember from our originals that we did, sine starts at 0 and goes up, cosine starts at 1 and goes down. So which one of these is the sine of x? Yeah, it's this one. And when you hit that, it graphs the sine of x. It starts at 0, goes up to 1 at 90 degrees, back down to 180, at 0 at 180, and so on. Notice it has a period of 360. That's it. So if we wanted to graph the sine of x, that's it. You just hit submit. What about the negative cosine of x? All right, let's see how we're going to do that. This problem says find the negative cosine of x. So choose which one of these looks like cosine. It's not that one, it's this one because it's supposed to start up here at -1. The trouble is that is y equals the cosine of x. And we want it to be the negative cosine of x. So we need to flip this. How do you flip it? Well, you grab onto a point, like let's grab onto this point, and instead of having that point be at 1, watch what happens. I'm just going to bring this point down here to -1. So all I did was flip the cosine graph. Instead of this point being up here, I just flipped it to down there. And that's it. How about this one? 2 times the sine of x. Sorry, you couldn't see that. 2 times the sine of x. Well, choose the graph that looks like sine. Remember, that one's sine, that one's cosine. Choose the graph that looks like sine. And what's happening this time? 2 is the what? That's the amplitude. This graph has an amplitude of 1. I want to change it to an amplitude of 2. So let's grab onto a point and drag it up to where it's at the 2. Okay, nothing changed with the period. All I did was change it to an amplitude of 2. And that's all I have to do. All right, let's go up a level and see if we can make these problems a little more difficult. Let's jump a level, see if they can do something. Let's jump a level again because that's just amplitude. You know that's going to be flipped and it's going to be a half. I want to see if we can do one with the period. There we go. The sine of x over 2. All right, this one says find the sine of x over 2, or you can think of that as 1/2 times x. So let's take a look. Pick the one that looks like the sine, this one. There we go. It graphs for me the sine of x. But this time, it's the period that's changing. We want to figure out what is 360 divided by a half. 360 divided by a half is 720. So that means that this graph needs to be stretched out. It needs to be stretched out so that instead of having a full period from there to there, it only has a half of a period from there to there. So let's grab this point and let's move it from 90 over to 180. So let's move this out to there. See how that stretched it out? Now, they don't show that it goes all the way over here to 720, but it would start here and keep, oops, I just messed that up. There we go. But you can see this is really half of the period right here. Okay? Let's try one more. The sine of 2x. Well, what's the only difference here? Let's see. We're going to graph the sine of x. So choose the one that's the sine. That's this one. And then this time, what's 360 divided by 2? That's 180. So this time we have to make the period less. Instead of going from here to here, we needed to do the same thing to 90 degrees. So I'm going to move this 360. I'm going to move this 360 over here to the 180. Well, it didn't like that, did it? Okay, now it's all messed up. Where did I start with? We want the sine of 2x. Let's see, this still has to go up to there, but we want this point, right? No, that's not it. We don't want it there. We want it to go right through 90. There we go. Now we've got the same graph with the same amplitude, but now we've got the period being 180. See how it goes right through 180? And that's what you want. Okay? So I'd like you to try some of these on your own. Again, this is suggested practice, but try Z.11, and try some of these on your own. I think that the IXL does a good job of this, and I like the way it lets you manipulate the graph all by yourself. All right? Thank you for watching. Have a wonderful day, and we will talk to you tomorrow. Bye.